2011, we started robotics in engineering CAD. We introduced it. It was just a small little clawbot, they called it. Kids had fun with it. We saw that it sparked interest. The next year, we started a partnership with Tri-C. They were able to take some college classes, earn some college credit this past year, where we started with our own class here. We have 2 sections that are available for kids to take robotics. And then we also, after school, have Robotics Club.
So the Robotics Club is really a place where you can funnel all your creativity and energy into a robot that you can use to compete at the state, national, and worldwide level.
Every year, Vex Robotics, that's who we go through, they create a game.
So we started with an assessment of what the challenges of the game would be. The main focus is to see how many points your robot can score. You want it to be able to be versatile, which means it can score all the game objects in many different places. And you also want it to be able to work with other robots that are in the arena as well.
You don't know what that game is until they present that game. And once they do that at the World Robotics Championships, then you start your process.
So we started with an assessment of what the challenges of the game would be. Last year we had to be able to manipulate cubes and pick them up, as well as manipulate skyrise pegs. We start the process off with a 6-step design process where we assess the problem, come up with many different ideas, and come up with sketches. Then we implement those sketches into a prototype, test that prototype, then make any changes off of that, and then share our results by going to the competition. This year we had 2 teams. We were both able to make it to the national level, and we had 1 team that also went to the world competition. So our program, as a second-year program, this is the first year we've made it to Worlds. We've won many awards. We've won collectively about 3 design awards, 2 excellence awards, and tournament finalist awards.
To win the Excellence Award, it requires several different aspects of robotics. Your engineering notebook requires that you go through interviews. This year we were interviewed from judges somewhere from NASA, somewhere from Carnegie Mellon, somewhere from MIT. It was a neat experience for the kids to have those judges asking them questions, being from those prestigious universities and places. The engineering notebook itself, what it should be is, if somebody else wanted to build our robot, there should be enough detailed plans in that engineering notebook that anybody can follow along and be able to build it.
So the engineering notebook documents a roughly 6-month process to designing the robot. We update that every day after we make any changes to the robot. It includes all of our sketches, as well as pictures of our prototypes. It includes the code that we programmed in it, and journals of what we did throughout the day. That really reflects our progress throughout 6 months.
We compete against teams from China, Great Britain, all over the world, and you were able to talk with them and see where their ideas came from, and that some areas like New Zealand had some really weird looking bots compared to ones that were here in the United States. So it was a neat experience for the kids, is just to broaden their horizons and see what else is out there.